Good afternoon, students. Today we will be discussing about the second experiment in Xilinx applications lab, that is design of full adder using pre-modeling systems. So we have already studied in theory part that modeling, pre-modeling systems we are having in VHDL programming. First one is behavioral programming, second one is data flow programming, and third one is structural modeling. Behavioral modeling, data flow modeling, and structural modeling. So we will be writing the full adder in VHDL in these three modelings. Before going how to write the VHDL code, just we will be going with brief. We have to first of all describe the truth table in terms of A, B, C in. Inputs are A, B, C in, and sum and carry. And we from the truth table 0 0 0 will be getting sum 0, carry 0, 0 0 1, sum 1, 0 0 0 1, sum 1, carry 0, 0 1 0, sum 1, carry 0, 0 1 1, sum 0, carry 1. So here we need two inputs. If more than one input is 1, obviously the carry will be 1. So 1 0 0, sum will be 1, carry is equal to 0, 1 0 1. Here also two inputs are 1. So obviously carry is 1, sum is 0. And 1 1 0, sum is 0, carry 1, 1 1 1, sum also 1, carry also 1. So we will be realizing the sum in terms of inputs. Then what will be having? A bar, B bar, C plus A bar, B, C bar plus A, B bar, C bar plus A, B, C. In theory part we have already described. By analyzing it, what we will be getting, that expression for the sum, what we will be getting is A exclusive, B exclusive, C. A exclusive, B exclusive, C will be getting for the sum expression. A exclusive, B exclusive, C will be getting for the sum expression. For the carry expression, what we will be getting? C out is equal to AB plus C A exclusive B. This is the expression we will be getting for the carry. AB plus C A exclusive B we will be getting. Otherwise, we can also have carry like AB plus BC plus AC. In both ways, we can have AB plus BC plus AC. See, any two inputs are 1, obviously output will be, carry output will be 1. Or we can have the expression in terms of AB plus C and get of A plus A exclusive B. Either this in this expression we can write, either in this expression we can write. And also, you can realize a full adder using two operators. A full adder using two operators. We can realize that is the part of the structural programming. First, we will be going with the behavioral programming. When we go with behavioral programming, it always best to analyze the truth table, and the truth table is converted into if-else statement. The truth table is converted into if-else statement. That means if A is equal to 0, B is equal to 0, C in is equal to 0, sum is equal to 0, carry is equal to 0. Else if A is equal to 0, B is equal to 0, and C is equal to 1, sum is equal to 1, carry is equal to 0. Else if, likewise we can go else A is equal to 1, B is equal to 1, C is equal to, sum is equal to carry is equal to 1. That means we can write a truth table in terms of hardware description language by means of if and else statement. So if you go with the behavioral coding, you can see already library IEEE. We will be using use IEEE.std_logic 1164 data. Here inputs are A, B, C in, outputs are sum and C out. Now we will be starting the architecture. In the process, these are the sensitivity list A, B, C in. Any change in A, B, C in, output changes. Now here you can see whatever we have in the truth table, the same thing we have replaced. So A is equal to 0, B is equal to 0, sum is equal to 0, carry is equal to 0. A is equal to 0, B is equal to 0, C in is equal to 1, sum is equal to 1, carry is equal to 0. A is equal to 0, B is equal to 1, sum is equal to 0. Likewise, we have written the code. Now, as is, this code will be copying it in our Xilinx simulator. This code will be copying it in Xilinx simulator. We will be going with the this code will be copying. So, I have already written for structural programming. Now, I will be so I have written the code. Library IEEE, use IEEE dot underscore for full adder, and I have written the same truth table, whatever the truth table we are having, the truth table that I have depicted as hardware description language. Now I will be checking the syntax, whether the code is having any errors or not. So there are no errors. Then I will be simulating. See the code 0 0 0, sum is equal to 0, carry is equal to 0. Then in next instance 0 0 1, sum is equal to 1, carry is equal to 0. 0 1 0, sum is equal to 1, carry is equal to 0. 0 1 1, if you take 0 1 1, sum is equal to 0, Cout is equal to 1. If you take all 1 1s, sum is equal to 1, carry is equal to 1. This is how we will write the behavioral programming. Now if you take the dataflow programming is nothing but the logic expression what we are having, Boolean expression, is converted into a concurrent statement. Here we are having sequential statement in full adder. Behavioral programming is a sequential statement, one after another. If it is not executed, it will go for the other statement. The statement is not executed, it will go for the another statement. That is a sequential statement. Whereas dataflow is a concurrent statement, whereas both can be executed simultaneously. Both can be executed. See, some A XOR B XOR C in Cout is equal to A and B, or C in and A XOR B. I have told you that the program can be written. This is nothing but the program what we have written is AB carry for the carry program, C in. This is the formula for excluder, excluder C. This is the formula for that case. Now, if you take this code, I will be going and I will be executing this code. So for dataflow programming, this everything I will be commenting. Then for this I am going with the dataflow program. So if I go with the dataflow programming, I am sharing. Now I will be executing. Same simulation viewer I will be running it for dataflow programming by giving the logic expression in terms of hardware description language. Now you see the same 001 10 011 sum is equal to 0, carry is equal to 1, 111 sum is equal to 1, carry is equal to 0. So in both ways, either in data flow we can design a circuitry, or we can in behavioral also we can write the programming. Now there is a structural programming. There is a structural programming. This is a code for structural programming. This is a code for structural programming. So, if I go with this, what is the meaning of this one is, first of all, we have to create our own components. See, the same library IEEE, use IEEE, these all will be same. When it comes to architecture, behavior of the FA2, component XR1, we will be creating the component. XR1 ki component we have to create. For OR gate, we have to create component. For AND gate, we have to create component. Then, here if you see the circuitry, first if you take this one into consideration, what will be the circuitry for this one? First, you will be having exclusive OR gate. Exclusive OR gate form, we will be having A, B, then output will be S1 for this one, this is. Then another gate from S1 it will be taking one output, and from Cin another input. So S1 and Cin are the inputs and sum will be the output. Now if you take AND gate is AB, BC, AC. Three AND gates will be getting. AB, output is S2, BC, AND gate, another AND gate, and AC, another AND gate. These three are connected to OR gate. One OR gate will be getting S4. Again this OR gate is connected to another gate, because we will be having two input OR gates. We have not taken three input OR gate. If three input OR gate తీసుకుంటే సార్ ఇప్పుడు ఎన్ని వచ్చాయండి గేట్స్? 2 XR gates చూడండి, ఒక XR gate, 2 XR gate, 3 AND gates, AND 1, AND 1, AND 1, 2 OR gates, R1, R1. So this is how we will be port mapping it, and we will be creating a circuitry. This is called the port mapping. So first of all we have to create the components, then we have to define, we have to interconnections by means of port mapping. By means of port mapping we have to interconnect the circuitry. So the same code I will be applying at the software. The same code I have applied across the software. Now if you check it, you see the same library entity port. Then we created the architecture. We here FA2. First of all, exclusive OR gate I have created, OR gate I have created, AND gate component I have created. Then middle signals I have taken S1, S2, S3, S4, S5. Those are the middle signals which I have created. Then I have port map. Then what I have done? I have written code for XOR gate, AND gate, and OR gate. For these three gates I have written the code, and now I am implementing it. So if you see, again for the three, either it is in data flow, behavioral, structural, the way we write the code is different, but what will be the result is same. So I hope you understand it. If you have any doubts, you please comment on this video. Thank you very much.